Hi, this video is going to go into stones. And by way of introduction, I'm Tim Nelson. I'm a jewelry designer, teach at FIT here in New York. I'm going to do two things. I'm going to discuss stone proportions, but at the same time I'm going to draw stones so you can see how both of those things take place. I'm going to start with the basic, which is a round brilliant. So, put down some notes here. Stone diameter is the girdle's diameter. Stone depth is the total stone depth, including both the crown and pavilion. Crown height, the thickness of the crown. Pavilion depth equals the depth of the pavilion. Pavilion is from the girdle to cubit, and the crown is girdle to table. Okay. Another phrase that's important here is diameter, minimum diameter. When I refer to a minimum diameter for a non-symmetrical stone, the minimum diameter is the narrowest or smallest dimension. For example, a 6x4 oval faceted stone. And it's worth mentioning all of this is for faceted stones today in this video. Has a minimum diameter of 4 millimeters. The reason the phrase diameter is used is because when you're thinking of stones, you're always comparing them to the basic, which is a round. So a round stone of 6.5 millimeters that's its diameter. 4 by 6, you're going to take the smaller dimension, which is 4 millimeters for its minimum diameter. For asymmetrical stones, all depth dimensions which I refer to in drafting as elevations, are based on the minimum diameter. Okay, so let's talk about what those elevations would be, or ratios. Table facet is 53% of the diameter. Crown height is 16.2% of the diameter. Pavilion depth is 43.1% of the diameter. Total depth is just the crown and the pavilion combined. Are deeper. All dimensions are deeper for color than for diamond, because colored stones were always cut thicker to allow them to have more color saturation. A good example might be if you have the stone, measure it. Otherwise, a good rough estimate would be, say, 20% crown and 55% pavilion. That's pretty thick, pretty heavy, but that should cover you. Okay, because when you're modeling stones, your main goal is to not end up with a stone that is too thick for the mounting. All right, so I have those there. I'm going to start drawing the stone. I'm going to draw a typical bridle, which is 6.5 millimeters. The reason that's typical is because 6.5 millimeter rounds are 1 carat, which is your typical bridle stone. So I'm going to draw a circle diameter, make it in a color that's obvious. Okay. Okay. For some reason, there we go. It was sticking. 6.5 for the diameter. Not 3.5, 6.5. Okay. So knowing this, to get the table facet, I need 53%. So transform scale, copy equals yes. From the center of the stone as my point of origin, which is 0 in this case. I could have also used 0 snap. Scale factor is 0.53. Okay, that gives me my table facet. Now, in order to establish the other dimensions, I'm going to just keep making scaled copies. I'll make one at 16.2. And I'll make one, I don't know why that didn't show up. Copy equals yes, 0.162. Oh, that's why. I forgot the point. And then 0.431. The reason, because 16.2% in Rhino speak is really big. Remember, in Rhino, your percentages are always a point, a decimal. So 53% is 0.53. So here I have everything I need to draw a round stone. I'm going to move these two reference circles out of the way. You'll notice that I use grid snap very often. I mean, well, relatively often. But the reason I use it is mostly just so I can move things out of the way. I don't use it when I'm modeling very much. But it's very useful as a reference. So if I want to put something back, I always know that it's a certain number of grid lines away. So I'll start with this. I want to draw the facets of the table. There's really no reason to go too crazy with this because I'm not modeling it, I'm just drawing it. So I'm going to draw a straight line from quadrant to quadrant. Like so. And then I'm going to offset this curve through point to mid-snap. So I can get a center line between the table and the girdle. Now I need to divide all of these curves by 16 because there are 16 facets in a round brilliant stone. It's always divisions of 8 or 16. So I'm going to come over here going to go to the Standard tab. I'm going to pick the Point button. I'm going to right-click on it for multiple points. Actually, no, I'm not going to do that. I'm going to pop it out, and I'm going to click on right-click Divide Curve by Number of Segments. I apologize. Make the seam, sure the seams are all in the same orientation and the same location on the circles, and then type in a number. Oh, sorry, I have to accept that first and then type in the segments. There you go. Now I'm going to start working with the Polycurve tool. I click on every other point. And that gives me my table. I'm going to go from the flat sides of the table and draw my star facets going out to that center line. I'm going to go from the points of my stars to my girdle to create the upper bezel facets. I'm going to draw straight lines to split the upper girdle facets. Now, for those of you who are more advanced than this, of course, I could use a polar array to create a lot of this. But I'm drawing it deliberately one line at a time, or one set of facets at a time. Now I'm going to do a polycurve going all the way around the girdle, clicking on every point. Creating a closed curve that is my new girdle. Throw that circle away and delete the points. Go to Select, Points, Delete. And get rid of my side reference curve. Apparently there was a mistake there. So there. That gives me the top view of a round stone. I'll continue this video in the next presentation.